In this section, we're going to talk about rational numbers. So rational numbers are numbers that can be written in the form a over b, where a is any integer and b is a non-zero integer. So notice the word rational has the word ratio in it. And a over b, well, that's a ratio. So that's where those two things kind of tie together. And the reason b cannot be non-zero, or b has to be non-zero, is because we're not allowed to have a zero in our denominator. And that makes an undefined fraction. So that's a rational number. Now, all of these examples fall under the category of rational numbers. So proper fractions, we've talked about these before. Proper fractions are things like 1 divided by 2, or 1/2, negative 5/9. So the numerator is smaller than the denominator. Proper fractions. And this is definitely written as a ratio, so it qualifies as a rational number. Improper fractions are also rational numbers. So things like 4/3, or 9/4, or negative 7/2. These are just random examples. There are plenty more. But again, the numerator is bigger than the denominator. That's what makes it an improper fraction. So next is mixed numbers. Mixed numbers are things like 1 1/3, or even negative 2 3/5. So there's a whole number part, or an integer part, in a proper fraction part as well. Those are mixed numbers. Integers are, so integers do not include fractions. So those are things like -4, -2, 0 is an integer, 7 is an integer, 10. So all the positive and negative numbers and 0, but no fractions. Variables, and the reason actually that integers can be rational numbers are because they can be written as fractions. Like -4, we could write that as -4 wholes. -4/1. -2/1, we could also do that. 0/1. These could all be written as ratios. So they're rational numbers. Variables also qualify as rational. So, I should say, they can be part of a rational expression. So something like b/4, that's a ratio. Or 2x/5, 3a/4b, 1/c. These are all rational numbers that include variables. So there are some decimals that we can classify as rational numbers. And in order for it to be rational, the decimal either has to stop at some point or repeat. If it's just a random decimal that goes on and on forever and there's no pattern, then it doesn't qualify as a rational number. So things that work are like 0.5, because that can be written as 1/2 as a ratio. If I had, let's say, -9.8, that's a rational number because it can be written as -98/10. Okay, let's say 0.8 repeating. That's equal to 8/9. So it repeats, so it can be written as a fraction, and therefore it's rational. So we'll add a little side note here. We'll say, as long as the decimal either terminates, so as long as a decimal either terminates, which means stops. We call those terminating decimals, ones that end. So like 9.8, that stops at 8. So that's terminating. Or repeats. It is rational. So if there's some pattern, 0.88888, that's repeating. The 8 is repeating. Therefore, it can be written as a fraction. So it's rational. Something like pi would not be rational. So if we're going to put a little other side note, pi, since it's 3.14159, blah, 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 there's no pattern, it goes on forever, it doesn't repeat. This would be an example of something that's not rational or irrational. So we'll say pi is not rational. Okay, there are plenty of other examples, but pi pi is a really common one. So then it says you can write a negative rational number in 3 ways. So if I had something like, let's say, negative 6 over 11. Okay, the negative sign is just out in front here. So another way I can write this is if I put the negative with the 6. If I made that negative 6 over 11. These two things are equal. I could also put the negative sign with the 11. All of these 3 rational numbers are equal. As long as I only have one negative sign, it's not going to change the value at all, because this just means do 6 divided by 11 and take the opposite. Negative 6 divided by 11 gives me the same as 6 divided by negative 11. You know, it's a negative overall. So just realize these are all the same. And then if you want to add, so this does not equal negative 6 over negative 11. Notice there are 2 negative signs there. So that is not equivalent to any of those fractions. If I have a negative 6 divided by negative 11, technically that cancels out and makes a positive 6/11. All right, so let's practice graphing some rational numbers on a number line. I'm just going to make one number line and put these all on there. So my numbers go from negative 0.5 all the way up to 2.75. So I'll go ahead and put 0 in the middle. And I'll make my numbers go up to 3. 1, 2, 3, since 2.75 is in between here. And then need to go back at least to negative 1, because I need to be negative 0.5. I need to plot that. Okay, so let's see. We'll plot 0.25 first. So 0.25 is equivalent to 1/4. Okay, so that means it's between 0 and 1. It's bigger than 1, but it's bigger than 0, but less than 1. And if I split each of my sections into 4 equal parts, 1/4, or 0.25, would be 1/4 away from 0. So that's 0.25 right there. And since it looks like I'm going to need fourths for this as well, I'm just going to go ahead and split all of my sections into 4 equal parts, just to stay consistent. Okay, next I'm going to plot negative 0.5. So that's just negative 1/2. So if I start at 0, I'm going to go back, or to the left, 1/2. This is negative 0.5. It's between 0 and negative 1. 2.75, well, 0.75 is equal to 3/4. So this is really the same as 2 3/4. So if I go over 2 3/4 would be between 2 and 3, because it's bigger than 2, but it's not quite 3 yet. So here's 2 1/4, here's 2 2/4, and here's 2 3/4. So 2.75. Okay, there's some practice graphing rational numbers. And we're actually just going to do these examples right here. So, example 2, I guess that is example 2. Example 2 says, find the opposite and the absolute value of each rational number. So, negative 7/9. I need to find, first we'll think about the opposite. So the opposite, just like with integers, the opposite just means, okay, this is overall, this has a negative value, so the opposite has got to be positive 7/9. And then the absolute value, just like with integers, means so it's the distance from 0. So negative 7/9 has a distance of 7/9 away from 0. Remember, absolute values are always positive because distances can't be negative. I can't go negative 3 miles to get to my friend's house. Okay, opposite of 3/8. It's positive 3/8, so the opposite, we take the opposite value, or the opposite sign. It's positive, so now it's going to be negative 3/8. And I could put that negative here, I could put it here, or I could put it in front of the fraction. It doesn't matter where. Absolute value is just, so it's already positive, and the absolute value is a distance, which is always positive. So absolute value is just 3/8. Opposite of 10 over -3. 10 over 10 -3rds, I guess you could say. So the opposite, overall, this is negative. Okay, so, because remember, this is equivalent to saying like -10/3. So overall, oops, that means the same thing. So overall, this is negative. So to take the opposite, I need to make it a positive 10/3. And then the absolute value is its distance from 0, which means just if it's negative, make it positive. If it's positive, keep it positive. So I'm going to make this positive 10/3. And that's my absolute value.